right, ladies and gentlemen, it's our very first lesson that we're going to get into talking about math patterns. Okay? And we're going to begin to talk about this word or this word called sequences. And that's what I wanted to convey in this very first idea here, okay? So I'll stick with black here. So the main idea or the main understanding or the essential part of what we're talking about here is we're talking about lists of numbers. And let me give you an example here. Here's a list of number 2, 4, 6, 8, 10, yada, yada, yada. Okay? So a list of numbers, like spread out kind of like this is what we call a sequence. All right? This is called a sequence. So a sequence is just a string of numbers that's put together, right? And if it follows a pattern, then you may be able to predict certain things about that string of numbers, okay? So some patterns are more easy to identify than others, and some patterns aren't patterns at all, right? Some sequences are just strings of numbers that are listed together. What do you think the ... means on the end here? Yeah, it means it continues just as it would. Nothing changes or nothing deviates from what you see, okay? So in a sequence, we have to have a way of identifying elements in the sequence. And what I mean by that is the number 2 is an element of the sequence, right? The number 4 is an element of the sequence. The number 6 is an element, 8, and so on and so forth. These are all elements of the sequence. Well, we call these things, what's a name for them? We call them terms. Okay, so we're getting some vocab here. So terms are just what we call the numbers in the sequence. So for example, the third term would be what? 6. The fifth term would be what? 10. So on and so forth. Pretty straightforward so far. Is everyone still on board with me? Alright, so we're just getting some vocab here. Now, the way that we describe the terms is through the use of subscript. Okay? This is how we represent terms in the sequence. We use a capital lowercase a, and we call this 1, right? Capital lowercase a. This is the 2. Yeah, cursive a. Right? Let me erase these here for you, okay? It's a joke. And a sub 3. Okay? This is a sub 4. A sub big A, alright? But then it's not capital, it's just bigger lowercase a. That's a joke. Alright, it's a bad joke, but whatever, you guys get it. Okay, so look here. This is an important part. This is called a subscript of how we describe terms in the sequence, alright? So the fourth term, right, is denoted by this number right down here, right? So the great thing about certain sequences is that they can be thought of as functions. Here's what I mean. You give me a 1, I'll give you back a 2 in this particular case. You give me a 2, I will give you back a 4. You give me a 3, I'll give you a 6. You give me a 4, I'll give you an 8. There's a one-to-one correspondence there, right? All kinds of things happening. So if I kept going in this fashion, okay, if I kept going, then this over here would be the nth term. A sub n would be the nth term. And in this particular case, it's pretty easy to see that the way that I am generating my sequence here is I'm just taking the input and I'm multiplying it by 2. So a sub n is just 2n. So you need to get used to hearing these types of words and phrases being thrown around, all right? So a sub n is 2n. So my next question then is, if this term is a sub n, what is this term right after it? What's the subscript going to be? Very good. A subscript n plus 1. It's the one after it. Does that make sense to you? Okay, if that makes sense to you, then tell me what's going to be the one right before it? A sub n minus 1. It's a subscript, right? The n minus 1 is a subscript. All right? So I want you to think of these as inputs and outputs in terms of functions, because that's exactly what this is. All right. An explicit formula is going to be a way to describe... Yeah, to describe the nth term of a sequence using the number n. Okay? Using the number n. We just did this. We just found an explicit formula for that sequence that we did up above, and I'll point it out to you right now, all right? So as an example for part A, we looked at this sequence, 2, 4, 6, 8, 10, blah, blah, blah. We said that a sub 1 is the first term, a sub 2, 4 was the second term, a sub 3 was a 6, a sub 4 was an 8, a sub 5 was a 10. So we tried to figure out what's a sub n. A sub n was just 2n. So the way that we would say this, a sub n is equal to 2n. So I can now ask you, the beauty of the explicit formula is I could say, okay, what is the 50th term of the sequence? And you guys would tell me it would be what? 100, right? It'd be 100. What would be the 90th term of the sequence? 180. We're doubling it, right? Not cutting it in half, but it's the same thing, okay? Right? So let me give you another one here. Let me give you this one. Let's do example B, different color. I'll move this up. These are all explicit formulas. I'm going to tell you that a sub n, the sequence is generated by 3n minus 2. The generated sequence, we generate the sequence by the explicit formula a sub n is 3n minus 2. Let's write out together the first 5 terms. So I want a sub 1, comma, a sub 2, comma, a sub 3, comma, a sub 4, comma, a sub 5, and then so on. So how do I get the first term? I simply plug in, you give me a 1, I take your 1, I multiply it by 3, I subtract 2, what do I get back? I get a 1. There we go. So the first term of the sequence is a 1. Okay, you give me a 2, I multiply it by 3, that's 6, subtract 2, I would get 4. Then a 7, then a 10, and then a 13, okay? Hopefully you're realizing that this function is nothing more than the slope of a line. The slope is 3 and the y-intercept is negative 2, right? So a line, that's why lines are blown today in Algebra 2. So the difference, the difference between any two is going to be 3, which is what it should be, because the slope is 3, which is a constant, right? So that's why I want to really harp on the fact that functions and sequences are definitely related to each other, okay?
The point would be like 1, 1.
Exactly. The point would be 1, 1, 2, 4, 3, 7, 4, 10, right? All that. You got it. Okay, here's another explicit formula. A sub n is 12n plus 3. What is a sub 100? Well, it's going to be 12 times 100, add 3, 1,203, okay? That's a comma, okay? So that's the whole beauty of an explicit formula. Okay, there's also another way to define or describe sequences or patterns of the ones that we've been taking a look at. Let me give you an example of a sequence here, okay? 133, then 130, then 127, then 124, and then dot, dot, dot. Okay? All right. So if you were to describe this, I've heard people saying you're subtracting 3 and so on and so forth. Notice that I have not defined for you an explicit formula, right? In the sense of that, I have not done this. This is the very first term. This is the very second term. That's the third term. That's the fourth term. So I don't have this. You guys agree with me on that? In terms of inputs and outputs, right? If you give me a 1, I have to do something to that 1 to give you back 133, right? That would be an explicit formula. I'm talking about here a recursive formula. A recursive formula is one that builds off of the previous terms, okay? So as an example, many of you are already figuring out that I could say that, well, a sub n is going to be equal to whatever the term that I just had was, and then subtract 3, right? So here's how we would say that. We would say the term before a sub n would be what? A sub n minus 1. Whatever this term is, and then subtract 3. And we would say this for n greater than 1 because we would define a sub 1 as 133. So this right here is what's known as a recursive formula. It builds off of previously known terms in the sequence. So you have to know something about the previous term in order to generate the next one. I want you to notice that this is different than an explicit formula because I can no longer plug in, like if I wanted a sub 30, like the 30th term, I would have to know the 29th in order to get it. Does that make sense? Do you see this going on there? Alright, for this example, I'm going to give you some dots and we're going to draw a picture, okay? Here's the picture I'm going to draw you. One dot. Sweet. Awesome. Here's the next one. Okay. Here's the next one. Oh. Here's the next one. Doot 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 doot. Here's the next one. Doot 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 doot. And then I would keep going and going and going on and on, okay? So the question I have for you is this. Can we take my picture of dots there, my picture drawing, can we write out a sequence that would represent the total number of dots that I have on the page here? So can you do that with me? What would it be? 1, then what? 3, then what? 6, then what? 10, then what? 15. Okay, then I would keep going. Okay, I'd keep going, right? So here's the question. So here's what I have for you, all right? Here is the very first term, right? Here's a sub 1. Here's a sub 2. Here's a sub 3. Here's a sub 4. Here's a sub 5. And then so on and so forth, right? A sub n. I would like you, or like us, to come up with the recursive formula that would describe what you're seeing here, right? So how did I get from this picture to that picture? What did I add? Nick, what did I add? I added those two, okay? Now how do I get to the next picture? What did I add? I added these three down here, right? Nick, you had your hand up first, man, so I want to honor that. Can you tell me what would be the recursive formula? If I know this, a sub 1 is 1, that was given to me, right? How do I build the next term? A sub n is whatever the previous term was, right? What was it? That would be a sub n minus 1, and then what would I add on to it? N, very good. I would add on just n, whatever that n is, right? So as an example, to generate this, the third term, I would add on the previous term, which is 3, plus the n value of 3 to get 6. To get the number 15, I would add on the 10 plus the n of 5 to get my 15. So this right here is what's known as the recursive formula. Okay? Yeah. So if that's the recursive formula, does anybody see the explicit formula? Yeah, does anybody see the explicit formula in this case? Okay? Meaning, when you plug in a 2, I have to give you back a 3. When you plug in a 3, I give you back a 6. Plug in a 4, I give you back a 10. Plug in a 5, I give you back a 15. Anybody see it? A sub n is equal to n times n plus 1 over 2. Okay? So, right, think about it. The fifth term is just 5 times 6, 30 divided by 2. See that? The fourth term is just 4 times 5, which is 20, divided by 2, which is 10. So this right here is the explicit formula. Sorry, that was really ugly.